Hi everyone. All right, so this is the one of the first videos for our new section. We're moving into vectors. So Unit 7 is vectors, and there's some items from Algebra 1 in the beginning of the year that we need to kind of go back and talk about just a little bit so we can kind of see where we're coming from. And so we need to recall a couple of things. So the first thing is going to be slope. Okay. Slope, if you remember, you had a formula for, and hopefully when it was introduced to you, and it may not have been, it was introduced as the change in y over the change in x, which then led you to your y2 minus y1 over x2 minus x1 formula. So with vectors, the main thing we need to take a look at is this highlighted part, this triangle. This is the symbol for delta. Okay, and then what that means is the change in. So whenever we have those triangles, it represents the change in something. So when you do the change of y and the change in x, you're looking at that subtraction. Okay, so when we talk about the change in y and change in x, it deals with that subtraction that we introduced when we talked about slope. So then the second thing we need to talk about is distance formula. And we talked about this at the beginning of the year very briefly. So distance formula, if you remember, is d equals this massive square root, and it's just to be consistent with slope, we have x2 minus x1, the whole thing squared, and then we're going to have y2 minus y1, the whole thing squared. But what that really means is you have the square root still, but what you're really doing is taking the change in x and squaring it, and you're taking the change in y and squaring it. And that's something we're going to do in our vector unit. That's where the change in comes from. So we just need to be familiar with that terminology because we're going to say that a lot and use that a lot. We're not going to go back to what we've talked about with the y2 minus y1, x2 minus x1, that kind of stuff. We're just going to refer to it as the change in. So reviewing slope and reviewing distance formula, make sure you have that information because now we're going to move to our vector. And we're going to talk about what a vector is. So a vector, okay, is something that is a quantity that has both direction, so direction of some sort, okay, and magnitude. So magnitude deals with size, okay? So we use this a lot with physics, so dealing with force, velocity, even acceleration, okay? So that's a lot of where the vector is used. How you would write it, so let's say we had vector AB, we would just have a line with like a half arrow on top, and we would have something like this, like 3, 4, or it could be written as using your less than and greater than symbols. Okay, so you'll have some sort of what looks like a coordinate, But really what that represents is the change in x and the change in y. There's that change in again. Okay, so it's not necessarily a coordinate, it's you're taking their coordinates and you're doing the change with them. So if I were to graph this for you, just so you can see what it looks like. So we have a coordinate plane. If I had vector AB, and let's say vector AB was 2, 3. I can start anywhere. I'm going to go ahead, I'm going to start at 0, 0. I'm also going to plot if I started at 0, -4. So if I start at 0, 0, I'm going to go over 2 and up 3. And I would draw a line, like a ray, that goes through the point with the arrow um, going through it. I can start at really anywhere. 2, 3. As long as you're plotting your points correctly. So let's say I also had vector CD, and that was -3, -4. I'm going to start at 0, 0, and I'll do one at 0, -4 as well. So over 3, down 4. Okay, starting at the origin, I would draw it like that. If I was starting at 0, -4, I still would go over 3 and down 4, and keeping in mind my starting point. Okay, and that's really what it would look like in a graph, and you can have many directions, many different ones on the same graph, but that's the symbols and representation. So let's talk about magnitude real quick. Magnitude again deals with size, okay, and what that actually means, it's the length from your initial point to your terminal point. And we've used this terminology before this year, but essentially it's the length from a starting point all the way to an end point. Okay, so what that looks like if you're talking about magnitude, it kind of looks like an absolute value symbol around your vector. You can have vectors that are just letters. So if I had vector U or vector V and I was trying to represent magnitude, it would look like absolute value of those. Okay. So to find magnitude, and this is where our distance formula is going to come back into play. To find magnitude, you would take the square root of the change in your x's squared plus the change of your y's squared. So this is very similar to our distance formula. So let's say I have a vector AB that is 3, 4, and I want to find the magnitude. So I'm going to find the magnitude of my vector that I just created. So I would take my change in my x's plus the change in my y's. I would square those two things and add them together. So then this becomes square root of 25, which is 5. So what that 5 represents, okay, what that 5 represents, that's the distance from your starting point of point A to your end point, your terminal point of point B. So if we were to graph this, the distance between those 2 points is 5. This is why the distance formula is also related to magnitude because that's exactly what we're talking about. All right, so let's find the vector of 2 points. We're going to do a couple things with this. So I'm going to use some different letters. I'm going to say point P, and I'm going to use -3, +4, and Q. I'm going to use 1, -2. So to find the actual vector, okay, to find the vector, we are going to take the change in our x's and the change in our y's. We're going to actually try to find those. So I'm going to label my x1, y1, my x2, and my y2, and I'm going to do that subtraction. Okay, so I've got 1 minus -3, and I've got -2 minus 4. So my vector PQ should be a +4, -6. And you could also see that written with your little Pac-Man, alligator, less than, greater than symbols here. Okay, you can have either or, but that would be the vector for PQ. So now let's say I wanted to find the magnitude of PQ. Okay, so magnitude of PQ, I'm going to take the square root of my change in x's plus the square of my change in y's. So this is 16 plus 36, which is the square root of 52. So we're just going to check to see if I can simplify that anymore. And I can. 4 times 13 gives us 52, which means that the magnitude or the distance from point P to point Q is 2 root 13. So now if I were to graph this, just kind of making sure I have all my ducks in a row so you can see what that looks like. If I were to graph this, just so you can see it, oops. So PQ, vector PQ is 4, -6. I'm just going to go ahead and start at 0, 0. Okay. I used two different symbols. -6 with that. So I'm going to go over 4 and down 6, 2, 3, 4, 5, 6. And so this would be point P, this would be point Q, and this part right here would be the magnitude. That is the distance between those 2 points. All right. So the big thing you need to do, you're gonna, I'll put out some practice for this, but there's going to be a 7.1 part 2 Edpuzzle that you'll need to do for this. I will put an assignment in Classroom so you can practice your 7.1. So you can practice. Now, if you have any questions and you need any help, okay, we have office hours. And you can also send me a message on Remind and just let me know how you're doing. Keep in touch. I hope we're all doing well. If you need anything, just let me know. Have a great day.